Hello, it's Lexingtonmpi back with another video, and today we're looking at what? Impermanent loss. It's one of those things that all the YouTubers talk about, you've heard about it, and they say, oh, be careful of impermanent loss. That's the risk of dealing with liquidity pools and decentralized exchanges. But I find that no one really goes on to explain what it actually is in any great detail. So the aim of this video is to actually go into a lot of detail. This gets quite technical, guys, so if you need to rewind it or slow it down or pause it, don't be surprised. It goes into quite a lot of detail into exactly what impermanent loss is and how to calculate it and the theory behind it. So hopefully you'll enjoy. Please like and subscribe if you gained any benefit from this. Let's get started. So what is impermanent loss? So impermanent loss is the opportunity cost of supplying liquidity to a liquidity pool on a decentralized exchange. So due to how decentralized exchanges work, in certain circumstances, you would have been better off holding your cryptocurrency in your wallet, not in a liquidity pool on a decentralized exchange, and that would have been more profitable for you. And the difference between what you get by holding a cryptocurrency on the decentralized exchange in a liquidity pool versus the potential gains that you would have gotten by holding your cryptocurrency in your wallet, that there is the impermanent loss. If you would have made more by just holding the cryptocurrency in your wallet, then essentially you made a opportunity cost or theoretical loss versus you putting it on the exchange. Now, I'll explain how that happens and why that happens. What I think what will be useful is for us to quickly take a look at how we actually supply liquidity to a liquidity pool. So what is a liquidity pool? So a liquidity pool is where you, the user, is supplying the cryptocurrencies that are going to be used on the decentralized exchange by others, and in return you're given a percentage of each transaction. Because you're a liquidity provider, they want to incentivize you, and that is why they're paying you that percentage. So on Uniswap, which is one of the biggest decentralized exchanges, when you supply liquidity, they give you 0.3% of all transactions, which is pretty good. Also, when you provide liquidity, you're given an LP token in return. That token is for you to hold on to, and then you can swap it back for the liquidity you put on the exchange at a later date. The other thing to note is that when you supply liquidity to a liquidity pool, what you are essentially getting is a percentage of the total liquidity in the pool. A percentage of the total liquidity in the pool. I put that in red there and in bold because it's a very important concept that I will come back to later on in the video. So quickly, we're going to take a look at exactly how you add liquidity and how that works in practice to give a practical example. This all adds context to us actually getting into the main topic, which is impermanent loss. So here I am on PancakeSwap. This is my decentralized exchange of choice. Most of you will be familiar with Uniswap. What I'm going to do, I'm going to show you how to add liquidity, and this just adds a bit of context to what I was talking about earlier with a practical example. So swap is where you swap the cryptocurrencies, which is what most people do on decentralized exchanges. They swap some BNB for some, say, BUSD, for example. I put max, I want to swap all my BNB for BUSD, and it says I will get 222.8 BUSD, which fine. And as you can see here, you get as a liquidity provider fee. So I pay a fee to the exchange for the privilege of swapping from BNB to BUSD. This is similar to the fee that Coinbase charges you for using their exchange. But instead, that fee is going to the liquidity providers. And let me show you how you add liquidity so you can make some of that fee. Here it is. So what I can do on a decentralized exchange, I can add liquidity. So which means that when I'm swapping that BNB for BUSD, it's actually my cryptocurrency that is supplying those coins when someone swaps, right? So I can add liquidity and I can choose which two cryptocurrencies I want to add liquidity for. So therefore, I could do BNB and Alice, right? That means that whenever someone swaps between BNB and Alice, I will get a proportion of that 0.03% fee that is charged for each transaction. Fine. Now, what you have to do, you have to add equal amounts of each cryptocurrency. So the dollar value of each cryptocurrency you add has to be exactly the same. So I can add, there we go, 0.757 BNB, and I can add 54 Alice. But these have to be equal. As you can see here, I have more BNB than I have Alice, so it says I have an insufficient Alice balance. So what I may as well do is max out my Alice, and that means me adding 0.6 BNB, which is less than I have, which is perfectly fine. That's equal. 44 Alice equals 0.619 BNB, and I can supply that to the exchange. And that is how you add liquidity. So here we have the initial state of the decentralized exchange. So as you saw earlier, I supplied my cryptocurrencies in equal parts, equal dollar values. So in this example, we have 20 Ethereum and 10,000 DAI. Now DAI is a stable coin, so one DAI is always worth $1. So we have 20 Ethereum worth $500 each, which gives us a total value in the decentralized exchange or liquidity pool of $10,000. We also have 10,000 DAI worth $1 each, meaning we have $10,000 worth of DAI. So remember I said you need to supply 50-50 of each cryptocurrency in dollar value, as we can see here. And if you remember what I said earlier on the previous slide, which is this very key point, the price on a decentralized exchange is based on the ratio of the two coins in the pool. Meaning 10,000 DAI equals 20 Ethereum, which means one DAI is equal to 0.02 Ethereum and 500 DAI is equal to 1 ETH. How do we calculate that? Well, that's quite simple. What we do is we simply divide both sides by 20. So to get the value for 1 ETH, I divide that by 20, which gives me 1. 20 divided by 20 is 1. And we divide this side by 20. So 10,000 divided by 20 equals 500. So that is how we end up with those exchange rates. We have 10,000 DAI and 20 ETH, and that is the equivalent of what you see below here, right? Now, if I was supplying to this liquidity pool, and I supplied 2,000 of the $20,000, because we have 10,000 worth of DAI and 10,000 worth of Ethereum, right? I would have 10% of the liquidity pool. But if I supply 2,000, I'd have to supply it in an equal 50-50 share of the two cryptocurrencies, 1,000 each. So 1,000 DAI, $1,000 worth of DAI would be 1,000 DAI. Simple, because each DAI is worth $1. I also need $1,000 worth of Ethereum to match my DAI. So I need 2 Ethereum coins worth 500 each. And there I have supplied 10% of the liquidity pool. Quite simple, and that is how we start. So here we have the first transaction flow. So this is where we start to get into a bit more depth and a bit more granularity as to what happens behind the scenes on a decentralized exchange, how the values change, and this is key to understanding our impermanent loss. Don't worry guys, this is all about impermanent loss and it will all come together at the end. But follow me along so you can truly understand exactly how impermanent loss works. So in the previous slide, we had our initial state, right? We supplied 10% to the liquidity pool. This was the amount of each cryptocurrency in the liquidity pool, and these are the current exchange rates. We're all good, everything is fine. But then what happens? The price in the market on decentralized exchanges actually increases for Ethereum. So prior, 1 ETH, 500 DAI. What has happened since then is 1 ETH is now worth 1,000 DAI. So the price of ETH has doubled, right? So, and there you go, are the equivalent exchanges 1-to-1, right? Fine. However, because the price on a decentralized exchange, unlike a centralized exchange, isn't based on an order book, it's based on the supply of each cryptocurrency, the price is off. So that's how it was on the previous slide. But what's happened is that the price of Ethereum is now $1,000. So actually, I had 30,000 in the exchange, 10,000 in DAI, and 20,000 now worth of Ethereum. So it's not in equilibrium. But there's a natural commercial reason as to why this will rebalance itself. I'll explain that now. And it's all about arbitrage and arbitrages. So on the decentralized exchange, my 10,000 DAI is equal to 20 ETH, which means my 1 ETH is worth 500 DAI, right? Fine. So I get 500 DAI from my wallet. And I say, I'm going to go to this decentralized exchange and I'm going to put my 500 DAI in and I'm going to get 1 Ethereum out of it. Because the exchange rate on the decentralized exchange is based on the ratio between the two cryptocurrencies. So I have 20 and 10,000. So therefore, 500 equals 1. So I get my 500 DAI and I get 1 Ethereum. Fine, normal. And I take that 1 Ethereum and I take it to Coinbase. And Coinbase exchange rate says for 1 Ethereum, I get 1,000 DAI. So I've just made money. I've just made 500 DAI for spotting that the decentralized exchange pricing is off when compared to the Coinbase, the centralized exchange. So I take 500 DAI, make it into 1 Ethereum, and I take it straight to Coinbase. I turn that 1 Ethereum into 1,000 DAI. Beautiful. So arbitrage. So this is the definition of arbitrage. I'll read it out. It is a simultaneous purchase and sale of the same asset in different marketplaces in order to profit from tiny differences in the asset listed price. My difference wasn't tiny because I'm trying to give an extreme example to prove a point. It exploits short-lived variations in prices of identical or similar financial instruments in different markets or in different forms. So basically, 2 different prices, 2 different places. You're smart and you see this and you basically make money on the difference between the two, as I just explained. What is the role of arbiters? So arbitrageurs. Arbitrageurs will see an opportunity as above. They will trade between the centralized exchange and the decentralized exchange and make a profit. And this will slowly bring the ratio back in line with the market. And you're asking, how does that bring the ratio back in line? Well, as we saw here, we saw that 500 DAI went in, 1 ETH came out, and that 1 ETH was sold for the 1,000 DAI, making a profit. So that means that the new state of my decentralized exchange is now different because I've put in 1,000, or put in a 500 DAI and taken out 1 ETH. Let's take a look. So we put in 500 DAI, we took out 1 ETH. So that means I have 10,500 DAI and 19 ETH, right? So it's a different state of play now. And if you remember what I said earlier, the price on a decentralized exchange is based on the ratio of the 2 coins in the pool, not an order book like a centralized exchange. Meaning 10,000 DAI equals 19 ETH. Which means if you divide both sides by 19, so 1 ETH, so 19 divided by 19 equals 1. 10,500 divided by 19 equals approximately 552, which means 1 ETH is now equal to 552 DAI. Right? So now the arbiter can put in 552 DAI and get 1 ETH. They have to put in more DAI to get out the 1 ETH. Which means that when they sell the 1 ETH for 1,000 DAI, they make less money than before because last time they put in 500 and they got out 1,000. This time they're putting in 552 and getting out 1,000. So they're making a little bit less. So as we can see here, the value of the ETH is coming down. As it should, but we want to get back to an equilibrium point where these two are equal. We're adding more DAI and taking away ETH. So we're at So if we were at 20,000 and 10,000, and then now we're at 19 and 10.5. They're getting closer and closer together. And the exchange rate is getting closer to the Coinbase exchange rate. So what happens next? So we added 552 DAI, we took out 1 ETH, so where are we next? We now have, well, naturally 18 DAI because we took out that 1 ETH and added 552 DAI. So that means we now have 10,952 and 18 DAI. So as I said before, when they keep repeating it, the price on a decentralized exchange is based on the ratio, not the order book. So therefore, 10,952 DAI equals 18 ETH. So same as always, divide both sides by 18. So 18, so that gives us 1 ETH equals 608 DAI, which means it becomes even less profitable this time. So we need 608 DAI to turn into 1 ETH. I can take that 1 ETH, sell it on Coinbase, and make a profit, but it's less than before. So initially, I was getting 500 DAI and getting 1 ETH out. Now I need to put 608 DAI and getting 1 ETH out and selling it at a profit. Still profitable, still making money, but less and less each time. And as you can see, the amount of DAI is increasing and the amount of ETH is decreasing. And the values are getting closer and closer together. So as you can see, this would keep happening. As long as there's a difference in price between the decentralized exchange and Coinbase, there will always be an incentive for people who arbitrage to add DAI and take out ETH. Because the price on the open market has increased for ETH. And therefore, there's an opportunity to make money. And decentralized exchanges rely on this to keep their prices in line with the market. And they will because of rational economic factors. People will act rationally. If they can make money, they will. If there's an opportunity to arbitrage between the decentralized exchange and Coinbase, you're going to, because you're going to make 400 DAI for basically a minute's work. So if this continues happening, right, and we keep getting more DAI, putting it in, taking out ETH and selling it on Coinbase, eventually we end up in a situation where we have 14.14 ETH and 14,142 DAI. And at $1,000 in Ethereum, we end up with 14,140 in value here, and very similar amount here. The rounding errors cause imperfections here, but basically we end up with an equal pool, meaning what? 14,142 DAI equals 14.14 Ethereum. And we do the divisions again. Divide that by 14.14 equals 1, and divide that by 14.14, you get 1,000. Oops. So 1,000 DAI equals 1 ETH. So the decentralized exchange is now equal to Coinbase. Now, you're thinking, what the hell did this have to do with my impermanent loss? I will now explain. So remember, we started here. You put in 10% of the pool. So you put in $2,000 worth of cryptocurrency, right? And that meant you putting in 1,000 DAI and 2 ETH, right? Because at the time, 500 DAI equals 1 ETH, and you put in 10% in because the liquidity pool is worth 20,000, right? 10 and 10. So you put in 10% of the pool, so you put in $2,000 worth, and that was split 50-50 as you have to do on a decentralized exchange. So you put in 1,000 DAI and 2 ETH because 1 ETH is worth 500, so 2 ETH worth 1,000. So you had 1,000 worth of ETH and $1,000 worth of DAI. Calm. But don't forget, you own 10% of the pool. And as that pool rebalances, you still own 10% of it. So the key thing to remember, and I kept saying, is that you, where are we? Where is my little key thing that highlighted this to us? You own a percentage of the total liquidity in the pool. not the coins in it, a percentage of the total liquidity. So going back here to calculating the impermanent loss. So you own 10% of the pool. You put in $2,000 and you have 1,000. You put in 1,000 DAI and 2 ETH. Fine. When we got to the final state, when the decentralized exchange rebalanced because the price of Ethereum went up, you still own what? 10% of the pool. Right? 10% of the pool. So what is 10% of the pool now? 10% of the pool now, okay, is 1,410 DAI, give or take, and 1.41 ETH. Right? 10%. And that is worth $2,820. Make that clear. You now own 10% of the current pool. So you own 10% of the current pool. Yes, so you own 10% of the current pool. However, remember we put in 2 ETH and 1,000 DAI? If we hadn't have put that in the liquidity pool, and the price of Ethereum went from $500 to $1,000, what would that be worth now? That's your impermanent loss. It was the opportunity cost of putting your coins in the liquidity pool. So if we'd had 1,000 DAI, 1,000 DAI is always worth $1,000 because 1 DAI is always equal to $1. But your 2 ETH would be worth 1,000 each. So you'd have 1,000 plus 2,000 because they're worth 1,000 each, right? Meaning you in total would have $3,000 if you just kept your 1,000 DAI and your 2 ETH in your wallet. Because you put it in the decentralized exchange, and the decentralized exchange had to reduce this amount of Ethereum and increase the amount of DAI. So it reduced the amount of the coin that went up in value and increased the amount of the coin that stayed flat in value. Because you own 10% of the liquidity pool, you don't make the full 1K. You start off with 2,000, and you would have had 3,000 if you just kept it in your wallet. Instead, you have 10% of the pool, so you have 2,820. So where did the other money go? Where did the other money go? Guess what? The arbitrageurs took it. So every time they were taking their DAI and something if ETH, they were taking some of the impermanent loss is taken by the arbitrageurs. So I hope that clearly explains impermanent loss. Following through that transaction flow and how you don't actually own the cryptocurrencies you put in, you own a percentage of the pool. And therefore, when that pool rebalances because of price fluctuations, that could mean that you are better off owning your cryptocurrency outright, outside of the liquidity pool, rather than putting it in. Now, this does exclude the fact that you will have been earning the 0.03% fee for each transaction. So it is possible that the transaction fees you accumulate compensate for any impermanent loss. But that is a risk. And that is impermanent loss explained. I hope that makes sense to you all. And I hope you're able to follow. If you were, please like and subscribe. Lexingtonmpi. Have a nice day.